Really cool. Okay, so we know how to multiply out polynomials by hand. For example, and when I say polynomials, we're specifically going to be looking at binomials today. So we know how to multiply out binomials by hand. So if I had x plus 2 to the third power, I'd rewrite it as x plus 2 times x plus 2 times x plus 2, right? I'm not going to do that, but I could. We know how to do it. We could then multiply these two together, combine like terms, and then multiply it in here. That would take me not that long, still not that short though, right? Well, now let's say I take it and go x plus 2 to the 12th. That is going to be what I call a daunting task. Won't that take me all day long? And then there's a good chance I would do it for 30 minutes and get it wrong because there's so much room for error. So we're going to learn a cooler, quicker way to do this, and it's going to be awesome because it's so much quicker. We're going to learn a trick. So a couple things I want you to notice is, and you're going to want to take a picture of this while I'm explaining, is there's a couple patterns happening here. So we have x plus y to the 0. Hey, don't talk. In my video, guess what I can hear? Freaking annoying. No. Okay, so we have x plus y to the 0 equals 1. We have x plus y to the 1 is x plus y. X plus y squared is x squared plus 2xy plus y squared, and so on. Do you see how I just multiplied, taking the liberty of multiplying these out? Couple things to notice. Now I could keep going. What I want you to notice is a couple things. We have n plus 1 terms. So if we're talking degree n, then we have n plus 1 terms. So everybody look. N plus 1 means one more term than degree. So degree 0 will have 1 term. Degree 1 has 2 terms. Degree 2 has 1, 2, 3 terms. Degree 3 has 1, 2, 3, 4 terms. Degree 4 has 1, 2, 3, 4, 5 terms. So how many terms would degree 12 have? 13 terms. Did everybody just listen to what I just said? Okay, how many terms would degree x plus y to the 100 have? 101 terms, you're right. Okay, that will always be true. Now I also want you to notice that the powers of x decrease as powers of y increase. So look with me. X squared, x1, x to the 0. Do you see how x is decreasing? Look, let's look here. X to the third, x to the second, x to the first, x to the 0. X to the fourth, x to the third, x squared, x1, x to the 0. So do you see how powers of x are decreasing every time? That's happening as our y values are increasing. So look, y to the 0, y to the first, y to the second, y to the 0, y to the first, y to the second, y to the third. Did you see how this is just backwards with our y? 0, y to the first, y to the second, y to the third, y to the fourth. Next thing, the degree of each term is n. So what that means is we have degree 1 here. So look, both terms have degree 1. Degree 2 each term has degree 2. That is 2, that's 2. Because 1 and 1, when you multiply, you add, right? So that's degree 2. You all see. Even though we can't add them, right? Not the same base, that's still considered a degree 2 and degree 2. Look, degree 3. So degree 3, degree 3, degree 3, degree 3. So look, degree 4, degree 4, degree 4, degree 4, degree 4, degree 4. Do you see how that's working? That's another pattern. And then notice the coefficients. Remember, a coefficient is a number in front of the variable. The coefficients increase and then decrease in a symmetrical pattern. So look, 1, 2, 1. 1, 3, 3, 1. So they increase, then decrease back down. 1, 4, 6, 4, 1. Do you see how it's happening in a symmetrical pattern? Now, we're not able to identify where that pattern is coming from. That's not the point here. But do you see how it's going up and then back down? So on the outsides, isn't it the same? Then as we work in, it's the same. In, it's the same. Does everybody see? Okay, cool. So those are just the patterns that will always be happening when we're multiplying out binomials of any degree. Is everybody good with that before I move on? Okay, now here is where the coefficients come from. So the coefficients are the number in front of the variable. It's called the binomial theorem. Write it down. NCR. So N choose R. What that means is, and this is, you learned about this back in secondary math too, when you were dealing with probability and statistics. It's a combination. There's combinations and permutations, and if you really are curious, you can go back and review that stuff from last year. So NCR means it's the number of ways we can choose R in a group of N. So here's the formula. N factorial divided by N minus R factorial times R factorial. We have 10 minutes till lunch, according to my... So a factorial is actually, that's an interesting question. So a factorial is actually like literally just like a man-made symbol that they just said, this would be nice instead of writing out what it really means. So it's actually like not a mathematical thing. It's like a man-made notion or notation. So what factorial means, we'll get to it in a second. But it's just a notation that stands for, we'll get to it. So did you write the formula down? And that'll be the coefficient in front of x to the n minus r, y to the r. That will be the number in front of the variable. So you'll have to perform the formula here. So this is also how you could see it. NCR might be written like this. N choose R. So it just could be written either way. It's the same formula. So I don't want to hear people say to me when they see this, what's this? It's this formula. N factorial divided by N minus R factorial times R factorial. All right, so here's what we're looking at here. I'm going to show you something. If we were looking at x plus y to the 7th and we were going to expand it, let's just look at 7 choose 3 for a second and see what this means. So 7 choose 3 will be equal to 7 choose 4. And I'll explain why in a second mathematically. So you might even want to write that down in your notes. So 7 choose R will be equal to, it will simplify to be the same answer as NCN minus R. And I'll show you mathematically why that is. Now that's where that pattern's coming from. You know how there was the same number and we worked in and it was the same number in each piece? Because of this little statement right here. That's why we had it like, for example, 1, 4, 6, 4, 1. Sorry, let me go back. 1, 4, 6, 4, 1. Well, we just learned that coefficients are the same in some certain places. So look, they're the same right here. They're the same right here, aren't they? And then this one's a standalone. Okay. All right. So why that works here is because, well, I'll show you algebraically. So, well, once again, I want to really help this make sense so that it's quicker for you to think through. So this is an N, this is an R, right? So look, this is always going to work. 7 choose 3 will always be the same as 7 choose this minus this. What is 7 minus 3? 4. So they'll be equal. Does that kind of help on how you can quickly look at that? Okay, here we go. So let's plug this into our formula. So we would be doing n factorial. So we would be doing 7 factorial divided by 7 minus 3 factorial. Look, I'm just plugging it into my formula. Times 3 factorial. I'm just plugging it into the NCR formula here. Are we good? That's even actually quite quick to memorize. Let me show you how to just look at it. So you'll always do this factorial divided by this minus this factorial times this factorial. So it's kind of like this, and then this minus this times this factorial. So it kind of like works in a little, do you see how my brain is memorizing it as we go? Okay. All right, so let's simplify what this really means. So 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. So factorial just means start at the highest number and then work your way down to 1, multiplying it all out. So literally the factorial is just like a man-made notation to write out this. All right, so now don't we have divided by, what is 7 minus 3? So I actually should probably hurry and write right here, this is a 4 factorial. All right, now 4 factorial would be 4 times 3 times 2 times 1. And then isn't 3 factorial 3 times 2 times 1? And now we know we can divide across a multiplication sign, so let's just start simplifying this the easiest way. Want my 4's divide out? 3's, 2, 1, sweet. And now, so essentially, look at it. Didn't 4 factorial divide out? Cool. Now let's continue simplifying. We have a 6 on top. It divides with 3 on bottom and becomes a 2. Now look, doesn't this 2 divide out with this 2? Okay. And then what's left over? 7 times 5 is 35 divided by 1 is 35. So that will be the coefficient. That's how I found the coefficient. Now that's the coefficient in front of x to the 7 minus 3. So x to the n minus r, which is 4, and then y to the r, so y to the third. Now, once again, why is this kind of, once again, what pattern do we know? Well, we were looking at x plus y to the 7th. Look, won't this be degree 7, everybody? So it's all making sense. Now, we don't know right now which term this is. We haven't learned that yet. Like, where does this sit in the problem? We'll get to that in a minute. I'm just showing you how to calculate NCR. Okay, now look, are they really, I'm going to show you, we know that this side is equal to this side. And we did all the algebra. I'm going to show you how to do the algebra a little quicker. It's just quicker thinking. Same algebra, just think more advancedly, because then you're going to be quicker when simplifying. So watch. We know 7 choose 4 is 7 factorial, correct? That factorial divided by that minus that factorial. So that would be 7 minus 4 factorial times that factorial. So we have 7 factorial divided by 3 factorial times 4 factorial, right? Now look how I would think through it in the future. Instead of actually writing out every piece of it like that, I would say I have a 4 factorial down here. So on top, I'm going to go 7 times 6 times 5 times 4 factorial. And I'm not going to write out times 3 times 2 times 1. Why not? Because we have a 4 factorial on bottom and a 3 factorial on bottom. And look, then I can just quicker divide those out. We did that anyways, didn't we? Look. But why not just write it like that and then simplify it quicker? Does that make sense, everybody? The math isn't any different. It's just thinking a little more advancedly. And now, yes, 3 factorial, we would need to rewrite. So we would still have to do 3 times 2 times 1. So then we would continue to simplify, and when we get 35, since they're equal. Okay, cool. All right, so this is how you really start out. So where do we use the NCR? Right there we were just learning what is NCR, how do we calculate it. Now I'm going to show you where it falls. So this allows you to find the coefficients, the number in front of the variable. So let's look at this one. X plus y to the 5th. How many terms will x plus y to the 5th have? 6. So I'm going to draw little slots. 1, 2, 3, 4, 5, 6 slots. Now it's degree 5, so it's going to be 5 and then choose 0 here. And then it just counts up. So this will be the first coefficient. 5 choose 0, then it counts up. 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. That's when I know I'm done. 5 choose 5, you see how it's the same. 5 and 5. Okay, now what do we know? We know that if we calculate these, it'll be the number in front of the variable. Next thing we know, isn't it true to say that NCR is equal to NCN minus R? Didn't we just learn that? We just learned that a second ago. So let's think about it. Look, 5 choose 0 will be the same as 5 choose 5 minus 0. What's 5 minus 0? 5. So 5 choose 0 is going to be the same as 5 choose 5. So I'm going to color coordinate here. Those two will be the same. So if I simplify this, I'm going to know what that is too. Does that make sense, everybody? Okay, now 5 choose 1. Well, what will that be the same as? 5 choose 5 minus 1 is 4. 5 minus 1 is 4. So this and this will be the same when we simplify. We just showed you why. Doing the algebra. Okay, 5 choose 2. What's 5 minus 2? 3. So 5 choose 2 and 5 choose 3 will be the same. All right, let's go ahead and calculate. Now we only have to calculate these 3 and then we know these 3. Here we go. Let's calculate 5 choose 0, everybody. So 5 choose 0, using the formula, will be 5 factorial divided by 5 minus 0 factorial times 0 factorial, which is 5 factorial divided by 5 factorial times 0 factorial. Is everybody good? Let's just write them out and then we'll go simplify them in a second. So this will be 5 factorial divided by 5 minus 1 factorial times 1 factorial, which is 5 factorial divided by 4 factorial times 1 factorial. And then this one will be 5 factorial divided by 5 minus 2 factorial times 2 factorial. So we're going to have 5 factorial divided by 3 factorial times 2 factorial. I think that's our one. Yeah, it is. Yeah. Here we go. Simplifying 5 factorial over 5 factorial is 1. Now 0 factorial is 1. Just go with it. Because here's the thing. Factorial is a man-made, made-up, let's say factorial just means multiply down to 1. So they can literally just say 0 factorial, we're going to call it 1. There's no mathematical reason. That makes sense. Just put, this is how I remember it. Any base raised to a 0 power is 1. So 0 factorial is 1. I don't know. That's not why, but it just helps me remember. So this simplifies to be 1. And then 5 factorial, let's simplify this. So, I actually want to make a point here, though. So we know the first one simplified to be 1. So this coefficient is also a 1. We know that, right? All right, let's move on to the next one here. So we did it in blue. So 5 factorial divided by, 4 factorial. So this 5 factorial is 5 times 4 factorial, isn't it? And then divide out 4 factorial. So this becomes a 5. Well, if that's 5, then this coefficient when simplified will be 5. And then let's do this one. So 5 factorial is 5 times 4 times 3 factorial. So look what happens. My 3 factorials divide out, and then 2 factorial is 2 times 1. So 5 times 4 is 20. 20 divided by 2 is 10. So then this is 10. So this is 10. Now that's just the coefficient. That's the number in front of the variable. And now we know that cute little trick and that pattern that was happening based on what I showed you a second ago. So looking at that. So now this was x and y. So let's go ahead. So we're going to go like this. Fill in the rest. It's going to start with the highest degree, x to the 5th, and then x's go down. X to the 4th, x to the 3rd, x squared, x to the 1st, x to the 0. And then your back thing, your y, will count up. Y to the 0, y to the 1st, y to the 2nd, y to the 3rd, y to the 4th, y to the 5th. Couple things, just checking to make sure I've done this right. It was degree 5 that we're expanding, so all of your degrees should be degree 5. Are they? Okay, it's just a quick little thing to make sure I didn't accidentally mess up when putting those in. And now all you do, there's your final answer. Simplify it. So looking at this piece, 1 x to the 5th, y to the 0. Y to the 0 is 1. And so then 1 times 1 is 1. 1x to the 5th. I just simplified that. Here we go. So then plus, because this was positive 5, so plus 5x to the 4th y plus 10x cubed y squared from that plus 10x squared y cubed plus 5x y to the 4th and then plus, well, x to the 0 is 1, so plus y to the 5th. And we just expanded that much quicker, believe it or not, than doing it by hand. The first time's the slowest. It gets quicker. So it really is so much quicker. Isn't that cool? Ooh, ah. Okay, I'm not going to outside. Thank you. Okay, let's do another one. Okay, let's do another one. So this is how you would do it from starting from the beginning. Here we go. Instead of doing this by hand and actually multiplying it out 4 times, you would say, how many terms does x plus b to the 4th have? 5, right? 1 more than the degree, right? So I would write myself out 1, 2, 3, 4, 5 slots here. There are 5 terms if it's degree 4. And then since it's degree 4, we're taking 4, choose 0, counting up. 4, choose 1. 4, choose 2, counting up. 4, choose 3. 4, choose 4. That's how I know I'm done, when it's the same. Now we know, let's think about it, we know a couple rules. We know that 4 choose 0 will be the same as 4 choose 4 minus 0. which is 4. So those will be the same. And then 4 choose 1 will be the same as 4 choose 4 minus 1. And then this will be all by itself. Here we go. Let's calculate our coefficients. Now, don't we only have to do these 3? So we know those 2. Here we go. 4 factorial. Let's do this quicker. 4 minus 0 is 4. I'm not going to show my work this time. 4 factorial times 0 factorial. So doesn't that simplify to be 1? So then this must simplify to be 1. All right, 4 choose 1 is 4 factorial using the formula. 4 minus 1 is 3 factorial times 1 factorial. So then I would go 4 times 3 factorial. Don't those divide out? So then I get a 4. That's 4. This is 4. And then we do 4 factorial divided by 4 minus 2 factorial, which is 2 factorial times 2 factorial. And then we know now simplifying that 4 factorial is 4 times 3 times 2 factorial. So look, I can divide those out. So I have 12 divided by 2, which is 6. So now I have my coefficients, and now filling in the rest is the quick part. So look in this one. We have an a in front, and so let's start there. So we'll have a to the highest degree, a to the fourth, a to the third, counting down, a squared, a to the first. Is anyone going to be mad if I do not write a to the 0? Because that's a 1. And then our b will be counting up, b to the 0, b to the first, b to the second, b to the third, and b to the fourth. And then they were all positive, so plus, 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 plus. And we just multiplied that out. There's our answer. Yeah, it's kind of cool. On the test, if I said to you, what term is 4 choose 2? What term is that? You'd have to say to yourself, the first one's 4 choose 0. 4 choose 1. 4 choose 2 must be term 3. So just some thinking, some deep understanding. Does that kind of make sense? Okay, cool. Okay, so now what's interesting here, now that you know how to do it that way, that's cool, but a mathematician named Pascal was sitting down and he started multiplying out different binomials to power 0. And he noticed that it always simplified to be 1. And then he started multiplying out different binomials to the first power, and he noticed that the coefficients always have a 1. And then he started multiplying out a bunch of different binomials to the second power, and he noticed the coefficients come out to be 1, 2, 1. Do you see how this triangle then, he started seeing that this triangle are the coefficients in front of our variable here. And it was always the same, no matter which binomial he used, so it contained that. So he noticed that this pattern always works, and that's when it was realized that this always happens, and that's called Pascal's Triangle. So Pascal's Triangle, isn't that what we just found, everybody? By doing the 4 choose, what was it? Degree 4. So look, degree 0, degree 1, degree 2, degree 3, degree 4. Now look, what didn't we get our coefficients from 4 choose 0, 4 choose 1? And look what we got. 1, 4, 6, 4, 1. Well, look, he recognized that as well. 1, 4, 6, 4, 1. You see? So that's what brings us to Pascal's Triangle. So here is the quicker way, instead of doing the choose thing, using Pascal's Triangle, because that will always be the same. Those coefficients will always be the same. So Pascal's Triangle is just a way to quickly give you, once again, the coefficients, the number in front of the variable. Now, you are not going to want to memorize this, are you? So I'm going to show you how to create this from scratch. You have to be able to create it from scratch on the test. It's really easy, though. It's just adding. Grab a blank piece of paper. Let's start creating it. Looking at it isn't enough. You've got to do it yourself. Here is Pascal's Triangle. So what I want you to notice is a couple things. Notice along the diagonals is always 1s. And then notice, to get this number, well, first of all, I guess I should say this first. This is x to the 0 power. This is x to the first power, which makes sense. Won't x to the first have 2 terms? So it's creating, you see how it's just creating a triangle? So look, the next line will have 3 terms. The next line will have 4, 5, 6, 7 terms, 8 terms, 9 terms, 10 terms, 11 terms, and we can keep going forever. So don't mess that up because a lot of people will call this x to the first and that will mess them up. Does that kind of make sense? Okay, so I'm going to show you how to create this from scratch. Ready to see it? So what you'll do is say, I'm creating Pascal's triangle. That'll be the coefficients, the number in front of the variable, when I'm expanding a binomial. So everybody put a 1. Then you put a 1 on your diagonals. That always happens. So look, on the top it's going to have 1 term, 2 terms. So we need to move on. We're done. Now put in 1s on your diagonal. Now we need 3 terms here. To find this term, you just add the 2 numbers above it. What's 1 plus 1? Now put it directly between those, just keeping it nice and pretty. So the first thing is put your 1s on the diagonal. So then I need 4 terms right here. You add these 2 to get the term right here. What's 1 plus 2? 3. 2 plus 1? 3. Let's keep going. 1s go on the diagonal. Look, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. What happens is when people get this messy and they don't have it lined up nice and pretty, it gets confusing on which 2 you should be adding. So make sure you really keep it nice and pretty. Okay, put 1s on your diagonal. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Do you see how we can keep going for as long as we need it? So if I said to you, find x, I need you to expand x plus y to the 12th power, the first thing you would do is say, I need to find the coefficients. So you'd have to go down to what x to the 12th would be. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I would need to keep going. 11, 12. I would need to figure out clear down here to be able to do that one. Does that make sense, everybody? And that's where you would start. And then once we know the coefficients, filling in the next part was easy, huh? The x's go up as the y's go down. All right, so take a picture, pull it up on your phone, do whatever you need to do. But once again, on the test, you have to be able to recreate this from scratch, which is just algebra. But once you've done it once today, just use that one every time. You don't want to rewrite it out every time. Okay, so does everybody understand how this works? So we can do some examples using it now, off of your homework to make it less homework. You're not going to probably, let's do number 1. X plus 2 to the 4th. Now, you might think, oh, it's quicker to just do it by hand. I promise you, once you get the hang of Pascal's triangle, you're going to love it. We don't even have to do the choose thing. That was just to help you understand where that was coming from. So, everybody locate on Pascal's triangle, since we're doing x plus 2 to the 4th, what are my coefficients? Here's 0, 1, 2, 3, 4. There's my coefficients, so we would start writing that out. Giving yourself plenty of room. 1, 4, 6, 4, 1. Now it's way quick because we don't have to do the choose thing because we have Pascal's triangle. And then when we start out with our x to the highest degree, counting down. Now one thing to note, if you check these little things, it's almost foolproof. You can't miss it. Degree 4 should have 5 terms. Do I have the right coefficients? 1, 2, 3, 4. Oh, 1, 2, 3, 4, 5. Yes, we're all good. Does everybody see what I did? Okay, here we go. X to the 4th, x to the 3rd, x squared, x to the 1st, and then x to the 0. I'm not going to write x to the 0. Is anyone mad? Okay, let's now take our positive 2 and do 2 to the 0. I'm not going to write it because isn't that 1? So then, but this one will be parentheses 2 to the 1st, 2 squared, counting up, 2 to the 3rd, 2 to the 4th. Now next thing, to make sure you've done this correct and not made any errors, is to check. If it's degree 4, then these should all add up to be 4 in each term. Don't they? So do you see how there's so many safe proofs that you almost can't miss it? Okay, let's simplify it. Here we go. 1x to the 4th is x to the 4th. Then when we have 2 times 4 plus 8x cubed, does everyone agree? And then we have 4 times 6, so plus 24x squared. And then we have 8 times 4 plus 32x. And then 2 to the 4th is 16. And look, we just expanded that binomial. Way quick. Now look how cool this is, because we know if we were to do this by hand, our last step is to put it in standard form. It's already in standard form, good to go. Yes. Yeah, you can. Just separate sheet of paper is great. Let's do another one. Isn't that cool though?
I think it's so cool.
Look, a plus 2 to the 7th power. If you did this by hand, you would probably get it wrong and it would take you 25 minutes. Let's use Pascal's Triangle. Now, once again, you've got to locate on Pascal's Triangle x to the 7th. So wouldn't that be the 8th line? Yeah. 1, 2, 4, 5, 6, 7, 8th line. So right here, I'm going to have you guys shout out those coefficients to me. You guys have got yours hopefully written down. So what are my coefficients? It was 1. And now it goes downwards, so I'm good now. Thank you so much for helping me out. So 35, 21, 7, and 1. When your work gets squished is when you mess up. So notice I really spread mine out. And now we'll start with our leading thing, which is A, and it'll be highest degree down. A to the 7th, A to the 6th, and so on. So you guys write yours in. A to the 1, A to the 0. So I'm not going to write those. I kind of like changing colors so I don't get it all mixed up. So hopefully you can spread yours out a little better and write small. Okay, so now we have 2 to the 0 right here. Does everybody see? 2 to the 0? Mm-hmm. I'm not going to write it out. Then we have 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, we're going to need our calculators, 2 to the 6th, and then 2 to the 7th. Now, the few things I always check, because it was so sad, this poor girl got to her test last year, and she just did these all wrong. She knew what she was doing, she was just missing little things. There's a couple ways you can make sure you're doing it on the right track. Degree 7 should have 8 terms. 1, 2, 3, 4, 5, 6, 7, 8. And then right now, before I simplify, it should be degree 7 in each, so count and make sure. Those are all degree 7s. And now we can say, yeah, okay, I've done this right, let's simplify it right. A to the 7th plus, this will be 2 times 7, 14, A to the 6th. I'm going to even cross them out as I go. Now look, isn't this 4 times 21, everybody? Which is? Plus 84, A to the 5th. Now we have 8 times 35, 8 times 35. Plus 280, A to the 4th. And then we have 16 times 35, plus 560, A to the 3rd. And then we have 2 to the 5th times 21. 6 what? 672, A squared. We're almost done. And then we have 2 to the 6th times 7. Plus 4, 48, A. And then our last one, 2 to the 7th. Did you say 128? And that was way quicker than multiplying that out. But look, we've done it right. It's in standard form, all looks good. So what's really incredible is this mathematician Pascal was actually multiplying it out by hand, and then he was able to see this and decipher it in his head and see the pattern of 35 is contained in there. Oh, it's also contained in there. So it's pretty incredible what he was seeing. Does that make sense of how he was seeing the pattern? It's kind of crazy because would we necessarily look at this and see, oh, well, 35 is in both of those. Oh, well, 21 is in that and that. And then see that there was always that pattern happening. It's kind of crazy, right? Yeah, they didn't have video games back then. Hey. Yeah, let's do this one. Now, this is actually on number 4, d minus 2 to the 9th, actually. Let's do it, though, because now we don't even have to be too mad about this. because it is long, but not too bad. I mean, not too bad. Okay, go ahead and tell me what the coefficients are for degree 9. Now remember, that'll be the 10th line, since we're starting at x to the 0 up there. So shout out the coefficients for me. I'm going to have to write kind of small on this one. And then back down, is there another 126? Yeah. Okay. I'm going to have to really squish. I might have to kind of write below just to keep it nice, not get all too squished, and then a 1. Okay, changing colors here. Okay, now D will be to the 9th, won't it? Starting out? Okay, I gotta get a better color here, blue. So then, here we go. Let's go. Can I write underneath it? Is that gonna bother anybody too much? Okay, so D to the 9th. And you guys get the picture. So you guys go for it. And then D to the 0, which I'm not going to write. And then -2. Oh, this is where negatives start coming into play. So now it's not really bad. It's just we've got to be careful. So -2 to the 0. This will be -2 to the first. Use parentheses. -2 squared. -2 to the third. -2 to the fourth. And so on. Counting up. All right, and now we've just got to simplify correctly. All right, so in my first term right over here, I have a -2 to the 0, which is 1. 1 times D to the 9th, won't that be D to the 9th? So this just simplifies. Now careful, this is -2 to the first times 9. Won't that be -18? So -18 D to the 8th, and I'm going to cross it out. Now, -2 squared is going to be +4. +4 times 36. Plus 144, and then D to the 7th. And then now -2 to the third is -8. So now we're going to be back into our negatives again. -8 times 84. 72. And then D to the 6th. Now look, in even degree with a negative base will be positive again. Now I want you to notice something interesting. Bouncing between positive, negative, positive, negative. Want to be positive again? Why does that make sense? You're on the right track because of? It's actually not a theory. It's just basically looking up here, telling me what's going on. Why is it bouncing between positive to negative? Odd and even degree. Who says that? Good. Very good. Odd and even degrees. Won't a negative to an odd be negative? And then won't the next one be an even power? The next one be an odd, so it'll be negative. The next one even is going to be positive. So it makes sense of why it's bouncing. Very good. Okay. Okay. Continuing. We're right here. -2 to the 4th is 16. 16 times 126. Shout it out. So 2016, well, better than doing it by hand, so you could really be complaining then. All right, and then -2 to the 5th is -32 times 126. -4032, and then that's D to the 4th. We're almost done. -2 to the 6th is even, so it's going to be positive. So type this in, use parentheses if you're doing it. Like, tell me what that is. 5, okay, so plus 5, just 5, 3, perfect, and then D to the 3rd, we're almost done. -2 to the 7th, you guys just finish this off here, and then shout out what you got. We're so close. What was the next coefficient, if you don't mind me asking? couldn't fit it all. Okay, are we good? That is way quicker than doing it by hand, though. Okay, cool. All right, let's go through number 5.
What are we doing? Just expanding?
Yep.
How do you guys want to expand? Do you guys want to expand? Or you want to do it by factorials? Shut your mouth for a minute. So, meaning, my way, do you guys want to do this? What's the first way you guys did here? I can't even think, dude. Or, no, I meant Pascals. What are you doing? I want Pascals. I would do it. What row do you tell them to do Pascals up to? Ooh, really? Whoa. What was this? Why is it 4? That's the 5th thing. Ah, she's good. She's good over there. Ah, yeah. Hey. So we know the coefficients are 1, 4, 6, 4, 1, right? Woo! Get excited, people. Get excited in here. Okay, so what's the power on 2x? Power on 2x. 4. Oh, I haven't wrote on this board. This was my board. What's the power on 2x here? Why? Because it decreases. You guys are so good. She's so good to you guys. I suck rocks. Anyway, we're filling this out. And there's how many's on this guy? How many 2x's on that one? Oh! You are a good teacher. Are we live? We're live? Well, not live. Okay, what's the power here? What goes with this guy? Whoa, -3 to the 0, right? You guys all understand why it's -3? Did you go already over a negative? You go over like a bajillion more examples. I suck rocks. Where's the eraser? It's been many moons.
I know.
Ooh, that's a big A eraser. Am I supposed to have them do more? This is what I do. Okay, what's the power on this guy? -3 to the what? What should these powers always be? Add up to be? I'm testing you, see. I wanted to see why you weren't in the dance. Or / your emails. Aggressive. Greenies. Did you get it? Well, there's 4 greenies. Pinky. 2 to the 4th. Oh, x to the 4th plus. See, there's me personally. This is a BJ Roberts thing. I come and get some purple up here, and then I say, oh, that's 4. Ooh, that's been a while. 8x cuber minus 3, huh? So is it a plus now? Suck it up, right? Not it. That's a big eraser. I like it. Man, you get a lot of steps in this. How many more examples you got? Am I taking too long?
No.
Negative what? Whoa, buckwheat. Really? Yes, it is. Darn it. I was thinking something else. Ooh, have you done some X's and some Y ones? No, meaning like 2x minus 3y squared. Oops. So this one's a 6, a 4, a 9er. 24 times 9er is 180 plus a lovely 36er.
Yes, but
2 16er.
Hey, they can't do this example. We gotta go on to this last. That was so funny.
I told you. I asked you if I was doing it fast.
I didn't know what time it was. Hey, last one. Well, this is my video, so I gotta have one more. Yeah. Wait, hey, you guys are good with finishing off that bad boy, right? Thank you for the helmets, Gerard. That was a good break for me. I wasn't trying to be rude. It's just, yeah, you did take too long. Just kidding. Okay, here we go. Third term of this. So this is one that's more reasonable to be on an ACT because this tests all of your knowledge in one. Because really, it's really going to test, do you know Pascal's Triangle and can you think through this? So let's do this. If we want the third term, I would make myself a little chart. Can't I stop there though? This is the third term in, isn't it? Now it's degree 10, so tell me what the coefficients are here, here, and here. 1, 10, and then 45. I'm only going to write that then. And then we know that x will be x to the 10, x to the 9, x to the 8. You're right. And then 3 to the 0, 3 to the 1, and then 3 to the second. So now we have 45, x to the 8th times 9, which is 508. I don't know. You tell me. 405 x to the 8th. And do you see how quick that one was? Because it just said find the third term. So that's a more reasonable one on an ACT, and I have seen ones like that. But I've seen students take the time on their ACT to multiply it out, and then they took way too long on the problem. Okay, are you guys good with that? Okay. All right, so this is what's required to do on the homework. The front page, cross out the back. Practice some. Watch the video if you need it. If you guys need me to finish this one, were you getting the picture here? You're sure? Not any different. It's just, okay. Please check your answers online. That's my only request.